Hey guys, welcome back to the former Farm Kid channel. I am in the process today of doing a tankless water heater flush. I have the Rheem 13 kilowatt tankless water heater. It replaced a tank that sat in this space right here that was a power vent, high efficiency 40-gallon water heater. These pipes right here were the exhaust vents for the fan on top of that heater. It took up a ton of space, wasted a lot of energy, and it worked pretty well, but it started having ignition problems, and it was, I believe, 13 years old, and the price of that tank had almost doubled. So I decided to go a different direction. Believe it or not, this little guy right here is just under 300 bucks, and it can power up 2 showers or a shower and a sink. And since that is more than I will ever need, I decided to give it a try. The hookup was not without challenges. Had to reduce some piping, put some new valves on here. Love these shark bite slip-on connectors. They're just marvelous. They're code approved to go inside a wall. That's how good they are. Did a little rewiring down here, some shielded wires, so that I didn't have to cut into my wall. I just had to poke through. There's actually a sub feed back behind this wall. And the toughest part was actually running the wires inside of here, because this is a 6-gauge 4-wire shielded cord. It requires that, a 6-gauge wire to power this up. 13 kilowatts, and it takes a 60 amp fuse as well. That's not a huge deal. Most electrical panels have those, and I was lucky enough to have a sub panel nearby that all I needed to do was run this electric cord to it. But since it is exposed for code, I needed to shield it. So what have we got going on here today? I have taken from this area right here this isolation valve off of my water heater. I had originally put it on because you generally need 2 of these to do this. And the directions, and rightfully so, the directions before you start doing this flush job is to check the inlet screen that is on the unit behind this line right here. It's inside of here. So that meant that I would have had to take this whole aperture off, which was this unit right here. This is what went into the heater, and I'll show you this conditioner unit that goes on here. But that valve hooked onto this elbow right here. So I was going to have to take all this off together, pull it all out, check the screen, and then put it all back together. Well, if you're going to do that and you have it off already, why not make up a simple little hose hookup for the flushing pump with the same compression fitting, a tiny bit of line, and again, these shark connectors are just wonderful. This is a shark connector here that has a hose hookup. Hose thread is totally different from pipe thread. You need a cold water input, which is what this line is here. Comes all the way down to the pump, and I'm actually cleaning it right now. So this pump is running. There is only one outlet on the pump. It goes into the cold water intake, and I thought about, well, wouldn't it be a good idea to flush it backwards? The directions don't say to do that, and part of that is I don't know how this is gauging water through it. I know, for instance, water softeners, to calculate water flow through them, actually have little turbines that are turning. And if you turn those backwards, what happens? Who knows? Now, does this unit have something like that? I have no idea. But at any rate, I decided not to run it backwards. So on the other side, then, I had installed an exit valve. And for code, you do need a pressure relief, even though I have this unit turned down so low that I can run my hot water upstairs full hot. So you get the best efficiency out of it that way, and you don't overheat your water needlessly. So this valve is pretty sophisticated. You have to put even though I don't need it, you have to put this on in order to block this from water running out. So when you start the pumping process, what I'm going to do is this little valve right here on the shark bite that puts my hose connection to it. I make sure that's on, so it's running parallel with the line. And then over here, I am going to shut this valve off so it's not running into my home supply. And by the way, I have shut-offs every place I can put them, and these shark bites are so easy to do so that you don't have dripping lines everywhere or having to catch water. So this valve gets shut off. This valve up here gets turned on, which allows water, which is the return flush fluid from here, going back into the tank. So that is a complete circular cycle. And the directions say to run it 30 to 45 minutes. I figured, you know what? I'll go the full 45. I don't think there's any harm in doing anything greater than that. And it recommends doing it every 6 months to a year. Since I'm by myself here in the house, don't use all that much water, I have gone with a year. And has it seemed to have been losing efficiency because of scaling? Not really. It's been doing a good job, but since I want to keep it clean and keep it running at high efficiency for as long as possible, I just decided to go ahead and stay with a 1-year flush cycle. Okay, I'm going to let it keep working, and when I'm done and I've got everything disconnected and hooked back up to the original setup, I'll do another part on this. So now the flushing is complete, and I have loosened this compression nut, and now I'm just going to slide my little aperture out of the hole. I guess I got to get my nut all the way off. It will slide right out once I get the nut off the threads. You might, and what I did when I took the input line in, before I took the hose off, I shut this valve off. Took the hose off, drained it, and then put a bucket underneath here and opened this valve back up. I only got a couple drops out of it because it wanted to flow into the water heater, because this valve here kind of creates a suction because of the line coming down. So it actually drew water when I opened this valve back up here. It drew this line back into the water heater. So I got no leakage. There may be a little bit now that comes out when I remove this. Nothing at all. That's great. Okay, so what I'm now going to show you is this little screen that I was talking about. Is back inside of the heater, and I'm going to try to move this. I don't know if I'm going to be able to get a better shot of this or not. No, because my lens is on the other side of the phone. So where my light is pointed there, there's a screen. You have to check that both times, before you start and then after you're done, because with all this junk flowing through the water heater, you need to know if this thing is clear or not. So I'm going to shut down here for a second and then replumb my input. Okay, guys, I went ahead and took that inlet valve out so that you could get a clear look at what the inlet screen looks like after the descaling process. So as you can see, it's pretty gooed up. So what that means is that I'm going to have to flush the water heater, which you normally do anyway to get the descaling fluid out of it. But I'm going to have to flush it backwards to get all that junk off of the screen. And we'll see how that goes. Okay, so here's the hookup for flushing in reverse. And the only reason I'm doing that is to clean that screen. Normally, to flush the water heater, you would just go and hook your input line from your well back up to your water heater and take this line here and run it down to a drain. But here's the thing, I'm doing the reverse. So this line is going to be hooked to the pump, which is in now clear water, and I'm going to leave the water running so the pump doesn't pump so fast that it empties the bucket, because it's going to take at least probably a bucket's worth of water or so, maybe half a bucket, to flush all the descaling fluid out of the water softener. So to run in reverse, it's the same hookup. This goes to the hose hookup on the descaling valve. You want the valve closed, and you want the valve on top here for this hose to be open. And all that's going to do from the pump, it's going to run fresh water back in reverse, admittedly, which is that good? Is that bad? Well, you know, how else are you going to clean that screen? I could maybe try a vacuum on it. That might be a good solution, but I'm going to give this a shot. Just run a gallon or so backwards through it. I did go online and check to see if there were any recommendations, and most people are saying that it's okay. So I'm going to give that a try. And this is the exhaust line, so it's just running down to the drain on the sink. Okay, good news. The screen is nice and clean. Flushing that out backwards, clean that screen beautifully. So now what I'm going to do is I'm going to reflush it in the forward, the normal flow position. So what I've done is hook the pump line, or my input line, back up to my input into the pump. I've replaced my water conditioner canister that is not a filter. It conditions hard water. It adds ions to the water so that it does not scale up the water heater nearly as bad. It doesn't stop it, but it is a scale inhibitor. So you do not want to skip in your installation putting this conditioner filter on. This proprietary T comes with it. It's got to be installed. There's an arrow right here, kind of hard to see. It's got to be installed in the direction of water, because this T directs water into the filter, the canister, and it has a special outlet inside it as well. And this canister is set up with outside holes and an inside hole, so that all the water that goes through this pump, all of it goes through the conditioner. Otherwise, you would just trap water down here and it would just be bypassing through the top. So when you buy this, you get this with it, because this doesn't work without that. So what you see here now is the input line minus this valve that I took off that I no longer need. Since I am checking this screen on the heater, that all has to come off anyway. So why use this thing? There are like, what? 1, 2, 3, 4 connections on that versus just one on this. So that eliminates 3 potential leak points. By the way, on this flexible stainless steel line, these fittings have rubber washers. So you do not need to torque the crap out of these, and you do not need to tape the threads either. The tape you see right here, Teflon tape, was for the previous valve, which did require it. But on this one here, as you can see, there's nothing to be put on this because this has a rubber washer in it. So you don't want to go nuts on tightening these. I tighten them by hand, and then I give them maybe another quarter turn with a wrench, because if you don't have the proper elbow here that has a flat seat for that washer, you could cut right through that washer by over torquing it to this fitting right here. So you want to be very careful that you haven't done that. So when you open your input valve, you want to do that slowly. So I'm going to flush this backwards. So it's going to mean opening this up. It means opening this valve to let the water flow out here, keeping this valve closed. I don't want that water to flow back into my house system until I have flushed this one more time the correct way, just to make sure that there's nothing else existing there. So this line here goes to a drain. So I'm just going to do that for a couple minutes, and then I'm going to go ahead and take this off, shut that valve, open this valve, and then open that valve. Okay, so here we are at the very end. We've returned the system back to normal status, which means the hose has been disconnected. The valve that feeds this line is shut off. Believe me, if you don't do that, this little cap here isn't going to stop much water. It's going to stop it from squirting you in the face, but it will leak if you forget to do that. Then I'm going to turn this parallel with a line that allows the water to flow back into the house, and then I have this line on. So I want to make sure all these valves are turned on before I turn the supply line on. And I'm going to do that very slowly. I don't want to shock that system by high pressure, because this does have water in it. So there isn't that shock as if it were empty. But still, you want to do it slowly, because you're going to check all the fittings that you put on. I never had to change that, but I did put this one on. And of course, this is a compression fitting, so that's got to be just right. You don't want to over torque that. And by the way, there is a place to put one wrench on the inside, and then the wrench on this side. And as you might have noticed, I haven't really talked about it. I put a little bungee cord on this valve appliance here because it is heavy, and you don't want to cause any stress to the internal plumbings of this unit. As a matter of fact, the manufacturer recommends that you don't do that by not putting a solid piece here. This is why I've got it supported. So it puts no stress up or down, in or out to this line. So I mounted this after I sought the neutral position by putting this line in first. They do recommend a flexible line there. And I tell you what, that was going to be pretty difficult. So putting the tube in, seeking its neutral position, and then matching all this stuff up here, and then anchoring it so that it cannot move is, in my mind, just as good a solution. Scalding themselves. And it's all automatic. It's all based on water flow. So as you can see, there was no damage done to the unit by reversing the flow on it, which I wouldn't expect there would have been. So it works perfectly fine. So in my mind, it is more efficient. The lower you keep that heat setting, it's safer. And again, I can run, I do have to add a little bit of cold water because 140 degrees is a little bit too hot. And because after it runs for a while in the shower, of course, it gets all the pipes heated up and blah, 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 and they're not pulling as much heat out of the water. So I do add a little bit of cold to it, but it's not going to scald anybody. So any questions, comments, guys, leave them in the comment sections. Appreciate the views. Give me a thumbs up if you found it useful. God bless you. Keep up the great work. We'll see you next time.